Welcome to Solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
In this question, it is given that a block of mass 4 kg is pushed to the right by a force of 20 Newton. A frictional force of 40 Newton is acting on the block while it is moved a distance of 12 meter. So let this is our block and its mass is 4 kg. A force F is equal to 20 Newton is acting on this block and a frictional force that is 14 Newton is resisting this block, and due to this it moves a distance of 12 meter and reaches this point. Now first of all we see the free body diagram of this block. So on this block four forces are acting. One is 20 Newton force, second one is this frictional force which is 14 Newton, and one reaction force that is normal force and weight of the block mg. Now in the first part we have to calculate the work done by all these four forces. So first, work done by force F, that is 20 into my displacement, that is 12 meter. So this becomes 240 joules. Now work done by frictional force, that is F into displacement into cos theta. Now this both are opposite to each other. So here angle is 180 degree. So now put the value of F, that is 14, and this is 12 cos 180. After solving this we get minus 168 joule. So this is the work done by the frictional force, and this is the work done by 20 Newton force. Now the third force is normal force. So work done by normal force is given by n into displacement into cos theta. Since normal force and displacement both are perpendicular to each other, so here angle is 90 degree. So this becomes 0. So work done by frictional force, that is W3, is 0. Now work done by weight of body or block, that is W4, which is mg into displacement into cos theta. Here also weight and displacement both are perpendicular to each other. So angle is 90 degree. So this becomes 0. So work done by this weight is also 0. Now in the second part, we have to calculate net work done. So net work done is given by adding all the work done. So W1 plus W2 plus W3 plus W4, that is 240 plus 168 plus 0 plus 0. So this becomes 72 joules. So this is our net work done. Now in the last part, we have to calculate the change in kinetic energy. So by the principle of work energy theorem, so work energy theorem, which says work done by all the forces is equals to change into kinetic energy. So work done by all forces is, we had already calculated, that is 72 joules, and change in kinetic, this is equals to change in kinetic energy, or I can write it as change in kinetic energy is equals to 72 joules. So this is the answer of our third part. Thank you.